All right, welcome to The Explainer. Today we're diving into something big, a massive scientific shift that could totally rewrite the rules for artificial intelligence. We're talking about a future where our technology isn't just imitating intelligence, but is actually built on the same principles as the real thing.
Now, you might be thinking, what if computers could learn and think, maybe even feel, more like a brain? For so long, that was just the stuff of science fiction, right? Well, it's not anymore. Something is changing, and it's happening because of a really wild new collaboration between, get this, brain scientists, AI developers, and a whole new breed of computer engineers.
Yeah, we're seeing this incredible merger of three of the most powerful scientific fields out there. You've got neuroscience, the folks who actually study the brain. Then there's artificial intelligence, which gives us the smart algorithms. And finally, this totally revolutionary new kind of hardware called neuromorphic computing. Three giants, all coming together.
And what's so wild is that for more than 50 years, these guys were all in their own lanes. Neuroscience was over here, decoding biology, AI was off chasing bigger and better algorithms, and then you had this small group of engineers, way back in the 80s, inspired by this guy Carver Mead, who were trying to build electronics that acted like brain cells. Totally separate quests. But now, all of a sudden, those separate streams are crashing together into this one massive river of innovation. It's happening right now.
Okay, so this is a new scientific frontier. Let's really get into it and see what each of these fields is putting on the table.
So here's a great way to think about it. You've got three pillars for a new kind of intelligence. Neuroscience, that's our blueprint. It's showing us the brain's super efficient design. AI, well, that's the software, right? The powerful learning algorithms like transformers. And then neuromorphic computing, that's the actual hardware. A brand new kind of computer chip that's literally built to think. Blueprint, algorithms, hardware. It's the whole shebang.
So first, let's decode the brain's blueprint. What are the secrets we're stealing from the original smart machine, the one inside our heads?
You see, the brain's real genius isn't just about being powerful. It's about being incredibly efficient. Think about it. It learns constantly by just rewiring itself. It saves a ton of energy because its neurons only fire when they absolutely have to. They're not just constantly chattering. And the physical wiring, it's a masterpiece of optimization, designed to use the least amount of material and energy possible. These are the exact design principles we're trying to copy now.
And get this, the human brain does all of that, all of its amazing complex thinking on just 20 watts of power. That's it. That's basically a dim light bulb. Seriously, remember that number, 20 watts, because it's going to be really important in a second.
All right, so you're holding that 20-watt number in your head? Good, because now we have to talk about AI, and the fact that AI is hitting a wall. And despite all its power, it has a big, dirty secret. That wall, it's made of energy. Just look at this, 493. That's the number of metric tons of CO2 that can be emitted from training just one family of AI models. To put that into perspective for you, that's like the emissions from over 100 cars for an entire year. And that's for just one training run. This is the core problem with where AI is heading. The energy consumption is just colossal. It's completely unsustainable.
And this brings us to the big paradox of today's AI, right? On one hand, it's incredible. It can write essays, it can code, it can make art. But on the other hand, it's super brittle. It's a total energy hog, as we just saw. It has zero common sense or real-world understanding. And it suffers from this thing called catastrophic forgetting. That's literally where, and this is a great analogy, it's like you learn to play guitar, and in the process, you completely forget how to ride a bike. That's AI right now. It's a powerful kind of intelligence for sure, but it's not always a smart one.
So, this is where that third piece of the puzzle comes in. This is where we start talking about computers that think differently. A completely radical hardware solution that's inspired directly by the brain.
And that solution is neuromorphic computing. What is it? Well, to put it really simply, it's about building computer chips that are designed less like a calculator and way more like a brain. So instead of one big, powerful central processor that does one thing at a time, you have millions of tiny, simple processors, these artificial neurons, all working at the same time in parallel.
This right here is the absolute key to understanding why this is such a big deal. We're talking about escaping something called the von Neumann bottleneck. Look, every single computer you've ever used works the same way. The processor is over here, and the memory is over there. And data has to constantly shuttle back and forth between them on this tiny little bus. It creates a massive traffic jam, a bottleneck, and it wastes a ridiculous amount of time and energy. Neuromorphic chips, they just get rid of that. They put the processing and memory right next to each other, just like neurons and synapses are in the brain. The traffic jam just vanishes.
And listen, this isn't some far-off theory. This is happening right now. You've got huge players like Intel building their Loihi 2 chip. You've got these massive European research projects, Spinnaker and Brainscales, building these incredible machines. Each one has taken a slightly different approach, but they're all marching toward the same goal, building hardware that actually thinks.
So, what happens when you finally put it all together? You take the brain's blueprint, you take AI's algorithms, and you take this new neuromorphic hardware. What does the future of intelligence actually look like? Well, what we get is a clear path toward a totally new kind of AI, one that runs brain-inspired algorithms on brain-inspired hardware. And this could lead to a whole new generation of intelligent systems. I mean, imagine robots that can learn and adapt on the fly, in the real world, or medical devices that spot diseases with insane accuracy and efficiency, or even a personal assistant that actually genuinely understands you. We're talking about a leap beyond just recognizing patterns to something that feels a lot more like real understanding.
But of course, getting there is not going to be easy. Researchers on this new frontier have some pretty critical challenges ahead of them. This is like their to-do list. First, they've got to get today's AI models to speak the brain's language, that super efficient, spiking communication. Second, they have to solve that lifelong learning problem, so AI can learn new things without forgetting the old stuff. Third, they need to give AI bodies, sensors, motors, so it can learn by actually doing things in the world. And finally, and this is probably the most important one, they have to build in the ethical safeguards right from the very beginning.
And all of this leads to a pretty profound final question, doesn't it? Are we building a new kind of intelligence, or maybe a new partner for our own? Because this whole convergence, it's not really just about making faster, better computers. It's forcing us to fundamentally rethink what intelligence even is and what it could be. So I'll leave you with that. Are we building a replacement for ourselves, or are we on the verge of creating a true partner in intelligence?